Hello, everybody. My name is Iurii. I'm a software developer in UBS. And every year I try to sum up what I learned. And one thing I will tell you today is what you most like to do is about coding. Yeah. So it's me. I have 14 years experience in backend development and 1 year in full stack development. And this 1 year actually inspired me from this presentation. So, agenda. I will read it from the list. Internet of Things, big data, machine learning, blockchain, Docker, clouds, AWS, Spring Framework, and other topics will not be covered during this presentation. Instead of that, we will talk about things you like the most, coding. And how it will look like, I like to switch between practice, theory, practice, theory. When you try something, and after that you learn how it should be, and after that you do another iteration. Bear with me for 5 minutes. It will be based on JavaScript, because that's where it's a source code manipulation has very good infrastructure, and with 2-3 lines of code I can show you how it works. But after 5 minutes we will switch to Java, so don't worry. And let's start from practice. Let me ask you, if you have a task to remove, you have some source code, a lot of source code, and you want to remove console.log, or in Java you can treat it as system out println. You don't want it to go to production. You want to remove it. How much time it will take you to write a code that will remove this line? Tell me. 5 minutes, 1 hour, 1 day? 1 second, 1 day, okay. Really different. How many lines of code you need to write to do this? Regex, 1 line. Yep. Okay. Let's make it more complicated. What if this function can have 0 parameters? It can have many parameters. Parameters can be regexp, or maybe you have some multi-line function, like you write console. And call function on another line. It may have comments somewhere. And in addition, you don't want to remove other stuff, like if it's commented out, you don't want to remove it. Let it be. Or maybe if it's console.error, not log, then you don't want to remove it. Or maybe if it's another some function, like myConsole.log, you don't want to remove it. So now, how much time it will take you to write a code that will remove those 2, but ignore those 3? 1 year. Other ideas? It's final requirement, yeah. 1 year, okay. What if I tell you that you can do it with, okay, guys at the end, I really encourage you to go closer, because unfortunately a lot of code here is at the bottom. I'm not sure whether you see it, but I will switch actually to real code and we'll try to move it up. Can you see it? People at the end? Right, cool. So, as you can see, okay, this is formatted code. It's 15 lines of code, but real logic, yeah, it's like what it means at all. I will explain you, because this is JavaScript world and you might be not familiar with it. There is a bubble. You can think about some plugin or small applications that actually take some input and run it. And what it actually does, it say, okay, I define visitor. And when I go through source code and I see some call expression, like function call, then I want to analyze object name. Yeah, I want to see object name. And if it's called console, I want to find function name. Oh, here it's named property name, but you can treat it as function name. And if it's log, then remove the whole object, or like remove the whole call expression. And if you do any notes during presentation, I really recommend you to write down AST Explorer, because it's something you can play even now online. Yeah, so you have this, and here you can see source code at the left. Here is you see source code manipulation, and here you can see outcome. Yeah, you see that this one is removed. Yeah, so I'm not cheating. I can change it to this, like 5, and you will see that at the bottom it will also be changed to 5, right? As easy as that. Okay, you can still say that you can do it with source code manipulation, with regexp. So let me switch to another example, because removing code is like not really hard thing to do. But what about this case? You start working on application, on Java application, but you really see that some C++ developer wrote it, and you see a lot of variables name that use snake case, like it use underscore, and you want to use Oracle code convention. Yeah, you want to use camel case. So now, how much time it will take you to actually refactor it, or write a code that will refactor it? Hour, day, sorry? 15 minutes, really? How? Okay, let me do it more complicated. You have constant, you have variables, you have functions that also you want to rename, and function parameters, yeah? And you want to see such output. Okay, so if you imagine, you just need to find what? Yeah, maybe, but if you don't want to, what if it will be inside string constant? You don't want to change your strings, right? Exactly. So we will go to it quickly, but just last example, like those literally 3 lines of code that will do. Like when I find identifier, okay, let me switch again to a real code example. Ouch. Like in JavaScript world, it's really easy. You say, when I meet identifier, and identifier it's literally name of your function, variable, parameter of a function, and you say that it contains underscore, then replace it. Yeah? Yeah? Question? Yeah. Yeah. That's a nice, and you know, I will tell a little bit why in Java it's not so easy. But in general, yeah, you can see output, yeah? So I can change it to something else, and you can see that it's immediately changed it.
Yeah, but will this change files on the GitHub?
On your local machine, yeah, you can write it like, yeah, so bubble in JavaScript world, it's actually change real file on your hard drive. And let me show you that it was so easy, but you know, all we did it was because we had access to AST, which is abstract syntax tree. And what is that? Let me show you an example. You can play with AST Explorer later, and it actually supports many languages, not only JavaScript, but you can play with JSON, you can play with PHP, SQL, whatever. But here is an example, yeah? So it's nice when I move cursor, you can see what is highlighted. So this is like the whole program is highlighted. This is a tree of objects, yeah? And later you can see that program consists of body, and it has 3 elements, which is, for example, variable declaration, yeah? You can see the first one is highlighted. And when you open it, you will see, okay, it consists of variable, it has kind constant, and it has variable declarator, which consists of identifier, which is like variable name, and init value, which is numeric literal and with value 1. This is abstract syntax tree. And why it's called abstract? Well, because why not concrete syntax tree? It's because it ignores, for example, formatting. It doesn't care whether you have it on new line, on the same line. It ignores some, for example, semicolons. It doesn't care whether you use semicolon. Or like if you have a list of parameters, it doesn't care whether you use comma, semicolon, or something else for separating your parameters. You will not see it in abstract syntax tree. You will see that just this is parameter. Yeah, that's why it's called abstract. Okay, it was good, but what about Java? Let's come back to Java. And with Java, it's not so easy as with JavaScript. Unfortunately, there is no such good infrastructure. There are a few tools to do it, but you still have to do some work manually. And for me, it was like, wow, it was so cool in JavaScript. Like you saw, literally, 3 lines of codes and you manipulate source code, right? Why it's not the same in Java? And it appears that actually we have different needs. If you think about JavaScript world, really, problem of these guys is that they have each year new JavaScript version, but they cannot use it because many users around the world use old browsers that support older version of JavaScript only. So what they do, they have this transformation. They write it in new syntax with new JavaScript version, and after that they use Bubble tools that actually convert it to old version of JavaScript. Looks ugly, but it works. With Java world, we rarely do source code manipulation because mostly, if you think about our tools, they use bytecode manipulation. If you think about Spring frameworks that use proxy, if you think about find bugs that actually checks your bytecode and other stuff, mostly they work with bytecode. And JavaScript doesn't have bytecode. They have to manipulate with with source code. Okay, so yeah, as you saw with JavaScript, it's easy. With Java, it's not so easy. And if you think you need to parse source code, and writing parser is really hard, and you can spend the whole of your life on this. So, what to do? And maybe before it, okay, what to do is I would really recommend you to take a look on Antler if you didn't earlier. It's another tool for language recognition. What it does, you define grammar for language, and it generates lexer and parser for you, as easy as that. And it actually generates parsers, for example, for Java language, for C#, for Python, JavaScript, Go, and so on, which is nice. So first, they actually release Java version of this tool, and after that, they migrate changes to all other languages as well. Okay, but let's come back to theory a little bit, because you heard about lexer, parser. What is that? So, maybe I will highlight it here, sorry. Yeah, as you can see, here is input code or source code. It goes to lexer, and lexer output will be list of tokens, like we have type int, we have identifier called x, we have operator equals, and so on. After that, those tokens go to parser, and parser creates this abstract syntax tree that you need to manipulate source code. Sounds maybe a little bit complicated for the first time, but just source code, lexer, token, parser, abstract syntax tree. Really, like lexer and parser will be generated for you. So how it looks like, for example, for Java. And you can easily actually find in GitHub Antler. There is version 4 already, and there are grammars for it, for different languages. So you can find grammar for languages like ALGOL, assembler, C, COBOL, Golang, GraphQL, HTML, and so on and so forth, even for Java. And how it looks, if we open it in a second. Okay. Yeah, we will have parser and lexer grammar, where you actually define some stuff like this. So what it means? You say that your source consists of such elements like variable declarator that has variable declarator ID, and you see this question mark. It means that everything inside parentheses is optional. So because you may initialize it with some value. Yeah, and variable declarator consists of identifier and something else. Yeah, and for example, what is identifier is Java letter and Java letter or digit. Because as you know, in Java, variable name starts from letter, and after that you can use digits. What is funny, you can even define something like not only condition like regexp here, like what is Java letter, but you can use some Java function to define whether you meet this criteria, which will work much slower, but still it's possible. You can even do some manipulation like, okay, I think I'm inside string here, but let me check what I received earlier. And you can check previous tokens and say, no, I'm not in string, I'm in regex. So let's switch context and say that it's another token. A lot of stuff it can be done. And when you generate lexer and parser, so let me show you how it looks in IntelliJ IDEA. I hope you can see it. So this is grammar that I actually copied from Antler grammar, and we have literals and so on. And when we actually run Gradle, so I use Gradle for build, and there are different plugins, Java and Antler. And when you just use this plugin, we will have, as you can see, another generate grammar source task that you can use to generate all of this. And when you run it, you will receive parser and lexer. So how it looks like. Yeah, bear with me a few seconds. It just define all the items that you can meet in source code. Okay, it can be literal, which can be one of integer, boolean, string, and so on, or null. But it's not so interesting. For what we will work most of the time is listener. So when you parse a source code, you can implement such method like enter package name or exit. So it always combination like enter something, exit something. Enter type name, and after that will be exit type name. And you can actually check on implement source method to do your manipulation. So let's move on to example like snake case that you already saw. Can you see it at the bottom? Okay, then great. So imagine you have such source code where you define class and some variable name. Now, I told you that in JavaScript world it was easy. Now in Java, you need to do a few steps. You need to create Antler input stream. So you take this string, you create Antler input stream. You send it to lexer, as you saw in theory, and it gives you a stream of token. You send it to parser, and actually with parser you start do everything that you need. And what you can do, you can add error listener, because there can be a mistake in your source code, so you cannot parse it, and you will receive error. And the most important, you can add listeners. So this is the item that actually react on something, like it meets variable name, and it calls your function, and you do whatever you need. So here is the implementation of snake to camel change in Java world. And you see it's very similar, like it's how it looks. You override one of many methods that you have in listeners. Yeah? So you can see enter literal, exit literal, enter primitive type, and so on. I'm interested in exit variable declarator ID, which is actually variable name. And I check if it contains underscore, that what I say, I ask rewriter, it's something that generates output for us, and I say, please replace all the text that is at the between beginning and end of this token position, and replace it with such text. And this like function that I wrote just to replace this underscore with camel case. As easy as that. So here is actually those really 2 lines of code that you need to write to do this manipulation. You have to actually check that you are in variable declaration, that it contains something, and replace it with something. So try it, use it. Okay, maybe it's so easy. Yeah, I told about this one. What about converting list of strings to, not a list of strings, but imagine you want to replace strings with text blocks. You know, in Java 13, we will have text box. So you don't have to write select plus another string plus another string plus another string. You can use 3 double quotes, and after that, write is like multi-line string. Yeah, or in Java 13, it's called text block. So imagine you want to replace this stuff with this stuff, right? So we want to, for example, remove new lines and so on. Let's do it, because I tried it in IntelliJ IDEA. I have the latest version. I have this text, this string, and it still doesn't have refactoring to do it automatically for me. But you can write your own programs that will replace, because such source code will be much easier to read. So let me demonstrate that it works. I will delete transformer text. This will be our input, as you asked about actually changing real files on disk. And let me run it. Okay. And here it is, it's created and it works. And it's smart enough, actually, the function that I wrote, that it will replace if variable initialization consists of string only, but if it contains another variable, that it will not touch it. And smart enough to remove /n at the end. So let's check how it works. General infrastructure is the same. I just read from file, not from string. And I write it to file. But we are interested in listener, actually the files that do all the logic. And we can divide it, okay, maybe I will show this. It will be a little bit bigger. We can divide it into a few phases. When we enter variable initializer, we define that, okay, I want to use 3 double quote, because it will be text block. And unfortunately, when we work with parser, we often work with state. Because if you think about this tree, you start parsing something, and you don't come back, you just go like one flow. Yeah? And sometimes Like in this case, I don't know whether I will be able to convert strings to text block, unfortunately, because maybe somewhere inside of initialization I will meet variable, not a string constant. That is why I added this Boolean field can convert to text block. So at the beginning, I assume that I can, and I start with 3 double quote. At the end, I will check if I can convert, and I will actually add 3 double quotes at the end, and will replace the whole initialization with new text block. But how we check that how we replace those strings? We have another function in our parser, exit literal, and it checks, okay, we still can convert it, great. And this literal is string literal, yep. So what we can do is actually remove first and last characters, because those are double quotes. And if we check if it ends on /n, we also can remove it. And that's it, and we collect it to string. And if it wasn't string literal, we say, no, we cannot convert it to text block. As easy as that. Yeah, there are some additional check. I check that each terminal, actually each leaf of this abstract tree, since we start analyzing initialization, is either string token or plus operator. So I actually check that text is plus, or if the node that we receive has double quote at the beginning and at the end. Easy check. You will have access to the presentation, source code. You can find it on GitHub, so you can play it yourself and see how easy it is. Okay, and I still have about 15 minutes, so let's think where I can use it. Because it was, okay, nice example, maybe I will need it. What example of usage I saw it? Because it really can be used really widely. So one of them is code transformation, as you already saw. And it can be many examples of code transformation. For example, we had a system that calculates specific business rules, but we had to migrate all those rules to another system. And there were like megabytes of codes. And it was like domain-specific language, and you need to migrate to another domain-specific language. Do it manually, and I think it will be a nightmare. So we were actually parsing one language and converting to another language. And during that, we had transformation like, okay, our system doesn't support some features that another system has. For example, our system allowed user to click all these rules. So it doesn't support something like if statement that contains function call. It supports only if statement that accepts some Boolean value. So what we had to do, if we meet such situation, we extract this function call here before if statement, call it, assign to function to some variable, and use this variable in if statement. So it's one of example called transformation, one you can see. Migration from one system to another. Another usage, code transpiling. So it's widely used. You can see, remember GWT, Google Web Components Toolkit. Actually, Gmail was written on GWT. Now they migrated to Angular, but earlier you can write your code in Java, and it was converted to JavaScript. Also, Kotlin, you can write in Kotlin, and it can be converted to JavaScript. Like you see this function at the bottom in Kotlin, and it will be converted to something like this. Yeah, it looks ugly, but it will work on your browser. Also, I saw another example. We had another project that used Lisp-like language, and they converted it to, it's called transpiling, it to C++. Why? Because writing its own compiler for many operation systems, for many hardware, different hardware variety, is really expensive. So what they did, they just transformed it to C++, and now you have a lot of compilers for different platforms that already optimize it and so on. Another tool that actually you use every day, it's like Checkstyle for Java, CodeNarc for Groovy, ESLint for JavaScript, KT-Link for Kotlin. Have you ever looked inside Checkstyle, how it works? Nope? Okay. Here how it looks. For example, one of the rules that check for, how it's called? For modifiers that are redundant modifiers. For example, when you define interface and you mark it as abstract, it's allowed by Java, but it's redundant modifier because interface is definitely abstract. So if you write it, Checkstyle will complain and say, no, you can remove this abstract. And how it works, it actually, they have some wrapper around this AST visitor, and they say, okay, please go into visit token method when you meet one of those tokens. For example, interface definition. And after that, they check. In visit tokens, they check, okay, if it's interface definition, check modifiers. And if there will be abstracts, they will log error. Another use case, for example, PMD. It's a tool that search for code duplication. Because you can copy-paste the code and change formatting, yeah? But if you transform it to AST, it doesn't care what is formatting. So you can actually check both trees and say, oh, they're the same, so this is code duplication. Codility, another tool. I'm not sure whether they use AST, but I would use on their place. For sometimes before interview, you have to resolve some task on Codility. You all have limited time, you have input, output. What is funny is sometimes I receive results. I need to check what our candidate wrote, and Codility often tell me, this solution is very similar to solutions that I received from another candidate. And it easily finds cases when variable were just renamed or it was reformatted. So it's also something that you can easily do with AST. Yeah, because it ignores formatting, and if you have different variable names, okay, you can go through AST and just rename all the variables to A or ABC, yeah, and check those AST trees. Reporting tools. Yeah, I saw another good presentation about reporting tools. Many of us work for enterprise application, work in enterprise, yeah, and we have big applications that has thousands of test cases. And imagine that you have a test case in Jira, you have a specific issue called test case, where you have all the steps you need to check. And developers actually automate it later. But your manager asks you, so tell me, what is automated already and what is not? Yeah? And instead of doing it manually, or adding some flags on Jira and making sure is it correct, is it outdated or not, you can do it in this way. You can actually request all Jira issues with type test case and get their IDs and go and use AST to actually go through source code and see. You can write annotation like with Jira ID and find them. Yeah, you can use simple text search, but what if you mark this test case with ignore annotation? Then you can also show this in the report, like, yeah, we have automated, but we ignore it because it doesn't work now. You can use it for IDE plugin. Actually, not quite. I mean, you will definitely need, and that's something we did, for our custom language. We define grammar rules, and for IDE, it's easy to write all this stuff like highlighting, like constant will be in another color, anything else will be in another color. The problem only is that you cannot use Antler grammar for this. Unfortunately, IntelliJ IDEA use another grammar called BNF, and the reason for that is it's faster. Why? At least theoretically faster. Because Antler can go through source code twice. wants to analyze something, and in another step they will do something. BNF always go like one flow, one time only. That's why it's faster. So we had to change, like, look on our ANTLR grammar, analyze BNF grammar, and rewrite it. Wasn't easy, but possible. Compilers. And here I would really recommend you, if you make notes, write down Google, GitHub, and GEL. This is articles that was written, set of articles were written by Jakub 3 years ago. And I believe that this set of articles will be relevant for many, many years. And what he really did, great thing, he actually write down a set of articles, 20 articles. Each of them are like 15 minutes reading. So we can do it after work, every evening. And he wrote down how to create your own JVM language. And you can do it like step by step. So he defined like, okay, here's theory, here's how I define grammar for class, for if statement, for methods, and how after that you generate bytecode so you can really run your application, your custom application. So I really recommend this. And if you need more about ANTLR, I would recommend you to start with this website, Tomassetti.me, where is a lot of a lot of documentation about how to start with, and you can subscribe to email list where there are a lot of interesting stuff and updates every week. So if you want to have access to this presentation and source code, you can go to this URL or scan this QR code with the URL. And that's it, guys. I was really glad that I'm here, that you're here. And if you have any questions, please ask. Yeah? Okay, any questions? Then thanks a lot, and please vote for this presentation, write your feedback so it can be better next time. Thanks.